California State Route 1, also known as the Pacific Coast Highway or the PCH, stretches throughout California along the Pacific Ocean from Mexico north to the Oregon border. The California Department of Transportation contracted with VSS International Incorporated to maintain a 22-mile section with 130 lane miles of pavement in southern Los Angeles County. More than 80,000 vehicles travel on this section of roadway each day as it serves as the main commuter, commercial, and beach route for thousands of local residents. This $6 million+ contract required nighttime placement of over 8 million square feet of slurry seal under intense working conditions between the hours of 9 p.m. and 6 a.m. Safety of both construction team and the traveling public were the highest priority on this project. Nightly meetings were held at the start of every shift to address the many challenges when it came to worker and public safety. As a result, there were no accidents, injuries, or safety issues on this project. Slurry seal is typically placed during daylight hours. For this project, VSSI's technical team created a Type 3 slurry seal mix design and emulsion formulation that was optimized for nighttime placement of over 900,000 square yards of slurry seal in a demanding coastal environment, and one that would sufficiently cure enough to handle the morning commuter traffic when opened at 6 a.m. The exemplary professionalism, communication, and partnership between Caltrans and VSS ultimately resulted in a project that was completed well ahead of the owner's anticipated schedule. This cooperation resulted in a superior project appearance and increased aesthetic value to one of the state and local shareholders' most valuable assets. The Type 3 slurry seal product provided Caltrans with substantial cost savings versus conventional maintenance methods and conserved significant amounts of energy and natural resources. VSS International is very proud that this project has been recognized as the winner of the 2020 IRF Global Road Achievement Award for the category of Asset Preservation and Maintenance Management.
The Ministry of Energy and Infrastructure is continuously aiming towards the development of balanced infrastructure capable to sustain itself through different environmental conditions. The construction sector is a major source of greenhouse gases, and under increasing concerns about climate change and growing construction activities, the whole sector is challenged to shift focus towards sustainable solutions. The UAE government today is urged to seek new approaches to reduce environmental burdens. Soil steel composite bridge, alternatively, was found by the MOEI to be a functional equivalent solution to the slab frame bridge and shows advantages in low cost and ease of construction. This method is favorable due to its easy constructability, low maintenance, as well as competitive cost. The MOEI has received several awards for this project. One of them is the Guinness World Records for the longest metal-buried bridge span ever constructed worldwide. This bridge is a part of the new development of Emirates Road E611 that extends from Dubai to Ras Al Khaimah, where the whole structure was constructed and operating in 10 months.
The livelihood of all types of people relies on this highway passing through a beautiful but fragile part of Taiwan. Over the years, the road's ability to resist the devastating effects of extreme weather and coastal erosion has deteriorated. Therefore, in 2010, the government launched plans for improving the Suhua Highway. However, to rebuild this road, we had to face tremendous challenges when dealing with the terrain's complex geological conditions and sensitive ecology. 3D model analysis, comprehensive studies, and detailed hydrogeological surveys helped to better understand the site conditions and finalize the alignment. Besides deploying different construction methods, innovative technologies mitigated the impact on the environment and responded quickly to any unexpected changes to the geological conditions. Among the Suhua Highway's features are 5 long tunnels equipped with an advanced emergency response and rescue system to ensure a safe drive home while passing through these narrow enclosed spaces. In the past, we mainly focused on how to overcome engineering obstacles and difficulties when building a new road. But today, we cannot help but also appreciate and preserve the surrounding natural ecosystems. So, for the Suhua Highway project, we developed a number of solutions that could enable us to achieve a delicate balance between road construction and protection of the environment. After embarking on this journey of building the new Suhua Highway, we're convinced more than ever that there's a proper way to maintain harmony between infrastructures and nature. After all, engineering construction should not be about building something cold or oppressive, but rather should be about building something that will sustain a radiant, life-giving warmth to its natural surroundings and users.
The Toowoomba Second Range Crossing is a vital piece of infrastructure connecting Queensland's agricultural engine, also known as Australia's salad bowl, to the west with the rapidly expanding economic powerhouse in the southeast of the state. The 41-kilometre road bypass reduces travel across the Toowoomba Range by up to 40 minutes. The bypass avoids 18 sets of traffic lights, removes freight from Toowoomba's suburban roads, increasing safety for Toowoomba residents, reduces carbon emissions, and creates a substantial economic link for future generations. The project undertook more than 20 million cubic metres of earthworks, creating 24 bridge works including an 800-metre viaduct, and laid more than 500,000 tonnes of asphalt. Culturally significant Indigenous heritage sites were acknowledged and protected throughout the project. The Toowoomba Range is home to sensitive and endangered native vegetation and nationally significant fauna, including koalas and the Delma torquida, or legless lizard, and other native animals. Specific care was taken to ensure these plants and animals can coexist with and thrive near this infrastructure. Water quality was protected by the construction of more than 180 sedimentation basins. 4 million square metres of exposed ground surfaces were rehabilitated to ensure soil conservation. By creating a vital link between Queensland's architectural engine to the west with the rapidly expanding economic powerhouse of the southeast, Nexus Infrastructure have created a sustainable link to Queensland's future prosperity, while protecting Toowoomba's rich cultural, social and environmental heritage.
The Integrated Road Investment Program, I-ROAD, was initiated with the objective of improving the roadways in difficult-to-access rural areas, causing the least amount of damage to the natural environment. The Asian Development Bank funded the program. The I-ROAD program is set up to run from 2014 to 2027 and comprises of 8 projects covering all 9 provinces. The pilot phase of the I-ROAD program commenced in 2015 in the Southern Province, covering Galle, Mathura and Hambantota districts. The I-ROAD project, owing to its meticulous planning, was able to protect the freedom of the wildlife that is so much a part of nature that the project had to go through. The project was also able to introduce a new road sign to mark on the road surface to indicate elephant crossing places for the first time in Sri Lanka.
iRoad project is much more concerned on environmental safeguards.
I have worked in 6 countries covering 3 continents, and iRoads is the most logistically challenging project I have handled.
The objective of this iRoad program is to improve the transport efficiency and thereby to enhance the socio-economic standards of rural communities.
The backbone of the project is called CSD, or Context Sensitive Design, which takes the sensitivity or the community values into the design.
The unique feature of this project is diversifying its scope beyond civil works towards people-centered arrangements to deliver user-friendly roads to the public.
Completing the iRoad Southern Province project has today provided the means by which the lives of thousands of people are uplifted by bridging and bringing closer the villages and the cities together in the project areas.
The Jiqing Expressway connects Jinan and Qingdao with the length of 309.2 kilometers, which has become the main traffic artery of Shandong Province. Its original 4 lanes are extended into 8 lanes via double-sided widening. The project is open to traffic and construction at the same time, with long mileage and great difficulty. One side, the old road was in operation for 23 years, so there were obvious differences in the material and structure between the old road and the new one. Based on the conception of long-life design, the permanent pavement, the new materials, the new equipment and technology were all used, which improved the durability effectively. What's more, the technological innovations were applied to achieve 100% material recycling of the old road, such as the milling material of pavement, the waste concrete, and the old guardrail, and so on. More importantly, the red mud was used to pave the base layer of expressway, providing an effective harmless way to resolve the problem of red mud pollution.
The application of a series of key technologies in the project improved the quality and efficiency of engineering obviously, and produced the direct economic benefit of more than 0.21 billion yuan. The technological achievements of this project provide certain references to reconstruction and extension projects in the later periods.
Permafrost underlies approximately 25% of land area of the world. Due to its unique characteristic of soil settlement, road construction on it has always been a great challenge. This is why most of the roads built in permafrost area are characterized by lower grade and higher distress rate. In the Qinghai Tibet Plateau, the permafrost is very warm and unstable, which would result in very high thaw risk when an expressway is constructed on it. Thus, the construction of an expressway on it is an unprecedented challenge for all human beings. In response, China initiated a series of research programs, investigating 150 million yuan. Scientists and engineers in China have been continuously working on this subject since the 2010s. By taking full advantage of over 50 years observational data and constructing a 15-kilometer road as a test and demonstration. The State Key Laboratory of Road Engineering Safety and Health in Cold and High Altitude Regions creates series of advanced theories, methods, and technologies for expressway construction in the permafrost area. The achievements were applied to the construction of the Gonghe-Yushu Expressway, which was 627 kilometers long and located at an elevation of over 4,300 meters. The expressway has been operating with an exceptionally good performance, proving to be a huge success.
Currently, road traffic accidents become one of the most pressing problems that need to be addressed in Thailand. According to World Health Organization statistics, Thailand was ranked the second most lethal in the world in 2015 with the 24,237 fatalities. To enhance the safety on rural road networks in Thailand, Department of Rural Roads, or DRR, has adopted road safety audit, a proactive measure, and road accident investigation, a reactive measure. There are three key stages of development. The first stage is to advance capacity building across the DRR community by developing DRR road safety manual and training DRR workforces by road safety experts from national universities and international organizations. The second is to develop the integrated road safety management system, which includes the Rural Road Network Management System, or RM. It's a web-based information system that provides rural road asset data. It can be used for conducting desktop road safety audit before visiting the site. The Road Safety Audit System, or RSAS, is the computerized system that can analyze the risk scores of rural road segments based upon IRAP star rating method. The Road Accident Investigation Dashboard is the accident database system. It can be used for searching and monitoring accident data on rural road networks. The final stage is to execute the road safety improvement projects and evaluating their effectiveness. The project outcomes. For the proactive measure, the total of 1,309 risk spots was treated. The results showed the number of accidents was reduced by 75%, and the number of fatalities was reduced by 52%. For the reactive measure, the results showed the number of accidents was reduced by 91%, and the number of fatalities was reduced by 90%. The estimated benefits from lives saved using both proactive and reactive measures were $130, which is approximately equivalent to 20 times of the improvement in investment.
A smart city is a safe city, and road safety is a must for any smart city. Hazen.ai uses the latest in artificial intelligence to make our roads safer for everyone. Our software identifies dangerous driving behavior in real time to generate event triggers, alerts, and actionable insights. Our driver safety suite identifies drivers talking on a mobile phone or texting while driving, and can generate an alert if a driver is not wearing the seatbelt. Hazen.ai software can be configured to identify different types of dangerous driving behavior, such as illegal turning maneuvers, block the box violations, and more. The red light phase detection module can detect the state of the traffic lights in real time, simplifying deployment and improving accuracy. Our video analytics software is easy to deploy on our edge processor and converts any CCTV camera into a powerful traffic sensor. This is the new generation of traffic management, providing traffic insights like never before. So let's partner and make our communities safer. Hazen.ai.
Lindsay is honored to accept the 2020 Global Road Achievement Award in the Urban Planning and Mobility category for the Richmond-San Rafael Bridge Shared Use Path Project. The Richmond-San Rafael Bridge Bicycle and Pedestrian Walkway is a 4-year pilot project and a key link in connecting over 360 miles of the existing San Francisco Bay Trail. The project had 2 priorities: crash-worthy separation between vehicles and non-motorized traffic, and quick and easy movement of the barrier for bridge inspections, maintenance, cleaning, repair, or traffic management. The solution that best met these criteria was a modified road zipper barrier from Lindsay called the RTS Guard.
What we try to do is move the barrier about once a month. We've chosen to lease the machine and hire Lindsay to operate it. It also has given us an opportunity to change the configuration of the bridge deck if we do need to maintain different lanes on the bridge. The movable barrier system really can close 1 or 2 lanes on either direction of the upper deck, and that allows us a lot of flexibility not only for operations of the bike ped path, but for getting behind a safe barrier system for maintenance activities. The movable barrier was a good solution if we could resolve the problem of rail height. We worked with Lindsay. They created a topper system which allows the rail to be the proper height for bikes and pedestrians. So we were very pleased with the result.
The RTS Guard barrier brings a measurable degree of safety and peace of mind to the shared path users. The barrier is tested to MASH TL3 containment levels with only 30 inches of permanent deflection in the MASH 310 test.
The bike path opened up in 2019 in November to a couple of thousand people riding it, and a great cheer of success in terms of connecting Marin and Contra Costa counties. We see almost 250 to 300 rides a day during the week. On the weekends, that doubles. I think this is a great investment for the Bay Area. I think it's a step in the right direction. We were concerned that it would not be a popular path. This path has exceeded those expectations, and we're hoping that will only continue to grow because people are going to need to use it in order to keep it.